Hello everyone, and welcome to Unit 3, which is the synthesis, qualitative and quantitative analysis of organic compounds. And in this first session, we'll be looking at stoichiometric analysis of organic analytes. Now, at the end of the session, you should be able to perform stoichiometric analysis of some organic compounds, especially vitamin C. So, with your first experiment, you'll be looking at the qualitative analysis of vitamin C, which in other ways will say the determination of vitamin C in urine. Right. So the method of determining vitamin C is based on its reduction features. Right. So ascorbic acid reduces the Tillman's reagent, making it colorless, and in an acidic environment, making it pink. So at the end of the day, the endpoint color you're looking at is a pink coloration of your solution after ascorbic acid has actually reduced the Tillman's reagent, right? So during the reaction, ascorbic acid is oxidized to the dihydroascorbic acid derivative. So in the process, before you start, it's however important because of the color change, which is very difficult trying to observe it or getting it accurately. It's better to prepare a control flask, right? That contains the urine, the water, and ascorbic acid, right? So this is a control setup, and at the end of the experiment, we are looking for the pink coloration, right? So to 200 ml flask, you add 10 ml of your urine, you add 100 ml of distilled water, and 1 ml of conc acetic acid. Now, the mixture is titrated with the Tillman's reagent until the pink color appears. Then you can actually calculate the amount of vitamin C in milligram using this equation. So after getting your endpoint, then you use your values to find the amount of vitamin C present. So these are post-lab questions you should look at or include after your report. So the structure of vitamin C, together with its properties, the importance of vitamin C for hydroxylation. You also have to know the vitamin C's antioxidant properties, and then the daily intake of vitamin C, sources of vitamin C, and then what deficiency of vitamin C can lead to. And then, of course, lastly, look at the method of detecting vitamin C apart from what has already been discussed or used in your experiment. Okay, so the next experiment, which is the second experiment, we'll look at the determination of glucose concentration in urine, right? And then we can use the Fehling's reagent 1 and then the Fehling's reagent 2 to help us in this regard. So the experimental procedure goes like adding 2.5 ml of Fehling's reagent 1 and then 2.5 ml of the Fehling's reagent 2, and then of course 20 ml of distilled water. Now you bring this content to the ball, and by heating it, you do your titration by adding the urine containing the glucose dropwise using a Pasteur pipette or a pipette, and then you look out for the endpoint. So the blue color of the solution turns green and then yellow. Now it will eventually turn back to the red color when the titration is complete. So the color of the urine is kind of yellow. So when you add the Fehling's reagent, as you keep adding it, as you keep titrating it, it comes, the color comes and goes back to the yellow color, the green color goes back to the yellow color until the persistent red color is observed. Then we can be sure that the titration is complete. And at that point, the volume that was required to convert this yellow color into the red color is taken, and then this is used to calculate the concentration in gram per liter in the urine, right? So this is how the concentration of the glucose in the urine is calculated using this formula. So this is also a post-lab question you should look at. You should be able to, you should draw the structure of glycogen and then add it to your lab report.